So 12-1, we just kind of, I'm not going to say look at basic probability, because basic probability I feel like is just one event, one item, what's going on with that. And we're jumping right in and putting multiple items together. But it's still kind of the basic probabilities and just, I don't know, maybe a review of all the probabilities you've done over the years and, you know, how they all work. So one of our big themes in this unit is how does describing events as mutually exclusive or independent affect how you find probabilities. So in this first page, we're going to talk about mutually exclusive events, what that means, how we do probability there. And then later on in this unit, or this lesson, we'll talk about independent and what that means. Okay? So let's jump right in. You roll a standard number cube once. Let E represent the event of roll an even number. Let T represent the event roll a 3 or a 5. Okay, so that's our scenario here. What is the probability that you roll an even number or roll a 3 or a 5? Jumping right to the answer. Okay, what are our thoughts leading up there? Okay, so standard number cube, basically, the math books always say standard number cube. What are they referring to? A die, right? Okay, a singular for dice, a die. It says event E represents an even number. So what are my even numbers? So 2, 4, 6. And I'm kind of setting it up as a circle, typical way to show events. Let T represent rolling a 3 or a 5, yes? Okay, now it says probability of an even number or rolling a 3 or a 5. So that means that any of those pieces work, right? Now, one way, and I'm going to take it a little bit farther, but one way is, can we just count those all up? You can. Okay, I'm going to take it a little bit farther and have us think about it in fractions here. But if we think about, basically they asked about probability of E or T. That keyword or versus and is a big difference in probability. So when you see probability of E or T, this is the probability of E plus the probability of T. Probability of E, there are what? There's 3 options out of, we talked about a number cube has 6 sides. Probability of T, there are 2 options, the 3 and the 5, out of how many pieces or out of sides? 6 sides. And 3, 6 plus 2, 6 is indeed 5, 6, yes? Some of you are going to say I went to a lot of extra work. Yes, I know, but I'm building for future problems, okay? So just, that's where it comes from. I'm not going to argue that you could have just counted and got 5 out of 6. Okay? Okay? Think about B. B asks us, what is the probability that you roll an even number and a 3 or a 5? What's the big change here? Probably you roll an even number and a 3 or a 5. So if I write it like this, it's a probability of rolling an E and a T, because E was what was defined for even number. T was what was defined for rolling a 3 or a 5. Thoughts on this one? What are we thinking about when it says and? No? If there was more than one roll, we could talk about being out of more possibilities, or we could talk about it multiplying. But this is still just you roll a standard number cube once, yes? Okay, we're rolling that standard number cube once, which means, okay, let me draw this in a different way. E was 2, 4, 6, yes? T was 3 and 5. Where's the and section there? Where's the and section in that picture? If you're rolling an even and a 3 or a 5, where's it going to have to land? We're looking for the overlap. How many numbers overlap between 2, 4, 6 and 3 and 5? None of them overlap, do they? Okay, so with that in mind, if we had some overlap, it'd be a different story. But since there's no overlap, that is 0 out of 6, which is just 0.
So by overlap, you mean like if it said and 2, 3, or 5 and evens, then the only possibility we could get both of them is if we roll 2.
Right.
Okay.
In other words, so when I'm saying overlap, if there was a number in common between the two groups, is what I'm saying there. Okay. In this case, 2, 4, 6, 3, and 5 had nothing in common. So I can't get something from E and something from T on one roll. If we're talking two different rolls, it's a different thing. But on one roll is the key here. Okay. And what does the probability of 0 mean? Just generally speaking, probability of 0 means it is not possible. That event will not happen. Okay. You can't roll something from both groups here. Okay. C. Watch your vocabulary. That means they're going to mark it in the computer. So, what is the probability that you do not roll an even number? So, not rolling an even number. So if I put it in this terms, and part of the reason I'm putting it in this terms, probability of not E, is that's often how probability is asked. Okay, if they're not giving you a word scenario, they'll often say, okay, probability of not E. Well, not E means not 2, 4, 6, but 1, 3, 5, and that's how many options? That's 3 options, yes? Out of how many possibilities? 6. And what do we know about 3/6? It reduces to be 1/2. Okay. Okay. So that's, you have to read carefully. We still got that catch there. This kind of some basic probability. Now, a little bit of vocabulary kind of applies to this, so I'll apply it to the next section too, but mutually exclusive events. This is one of our definitions that we need to be familiar with. Mutually exclusive events is when 2 events cannot happen at the same time. The events are considered mutually exclusive. If A and B are mutually exclusive, that's when you'll see the probability of A or B, and you are adding them. Okay, example A was mutually exclusive. We could not get an even number and a 3 or a 5 at the same time. So, mutually exclusive. Okay. And I think in this vocabulary, they just use something as either mutually exclusive or not mutually exclusive. I don't think there's also a vocabulary word inclusive, but I don't think you see it in this. I think it's just mutually exclusive or not. And another vocabulary, favorable outcomes. An outcome that is being tested or observed, but not necessarily a desirable event. So probability of an event is the probability of number of favorable outcomes over the number of total possible outcomes. So favorable, probability of rolling an even. Okay, your favorable options are the 2, the 4, the 6. Okay? Okay, questions there? Okay, next section. A box contains 100 balls. 30 of the balls are purple and 10 are orange. If you select one of the balls at random, what is the probability of each of the following events? So A is asking the probability that the ball is purple or orange. So we've got purple or orange. There were 100 total. 30 are purple, 10 are orange. And again, notice we are just selecting one ball. Okay, we've not got multiple tries here or anything. Probably the ball is purple or orange.
So just look in there and grab which one.
Huh?
Just look in there and grab which one.
But still, what's the probability? I mean, Patrick's trying to make it a 100% probability because he's going to look and he's going to grab a purple or orange. However, still, what's the probability that one of the balls is purple or orange?
2.
Okay, what'd you say? 40 out of 100. Okay, 40 out of 100. 2 out of 5, you're jumping to the end again. Okay, now, and I'm guessing a lot of you just jumped right into 40, but break it into pieces. The ball being purple. What's the probability the ball is purple? 30 were purple out of 100. Plus, what's the probability the ball was orange? 10 orange out of 100. 30 out of 100 plus 10 out of 100 is going to be 40 out of 100. And again, I know some of you are just, oh, that was easy. I said 40. I got it. But showing you where the pieces come from. In terms of reducing, well, I know my shortcut is that I'm automatically going to cancel a 0. If I cancel a 0, I'm at 4 out of 10. But 4 and 10 are both even, so they can reduce and become 2/5. While we're here, what are other ways you could express this answer?
2.
Okay. So, not one that I have written down and not one that I think they asked for in this lesson, but with a colon. What else did you say?
40%.
Okay, 40%.
What's a colon? Is that the 2 dots?
You sometimes see it done, although that's used more often in odds than it is in probability, but you do see it with ratio sums. So, as I said, I'm not going to include it because it's not one that they use in this particular lesson. Doesn't mean it's not valid. Okay, so 40%, how do we know 40%? It's 40 out of 100, right? What's another way to put this? Okay, a decimal, yes? 0.40 or 0.4? Okay. All of these are valid, right? Okay. We tend to, with probability, start with the fractions. But, 2 divided by 5, you can do that on your calculator, or we can go back and think 4/10 is 0.4, 4/10. Or 40 out of 100, 0.40. And then we can also change it to a percent by moving the decimal to right, or realizing something out of 100 is a percent. That's old news, but I've got to review it. Are we okay with that? Okay. Sorry if I'm boring you, but. Okay. B. The ball is not purple and not orange. Thoughts on if the ball is not purple and not orange?
Just subtract 40 from 100.
Okay. So the idea that the probability the ball is purple or orange is 40 out of 100, yes? So if we're taking that 40 and we're taking away from the total, which the total was 100, okay? Now, what if I use the idea of 1 minus 40 over 100? What does 1? So we talked about 0 representing that probability cannot happen. What does 1 represent? 100 out of 100 that it's guaranteed to happen, right? So the idea here is that if something is not purple and not orange, there were 40 purple and orange. So taking the 40 and subtracting it from the 100. That puts us at 60 out of 100. What are your thoughts about 60 out of 100? What do I have? Did you say 3 out of 5? I think that's what I heard. Okay. Reduces to be 3 out of 5 when you divide each of those by 20. It is indeed, since it was 60 out of 100, it is indeed 60%. And, okay, as a decimal, it is 0.60 or 0.6. Obviously, Savas will ask you for a particular form. Okay, they might want a fraction, they might want a percent, they might want a decimal. I'm asking you to be confident in all of these. Okay, so back to the idea of mutually exclusive events, which is, this is what we are talking about here, okay? If A and B are mutually exclusive events, then the probability of A or B is the probability of A plus the probability of B. And that's kind of what we did on part A here. Now, part B uses or represents the vocabulary word the complement. Okay, so that's a word you often hear with probability. The complement of an event is the set of all outcomes in a sample space that are not included in the event. If C is the event, then and that A does not occur, then the probability of C is 1 minus the probability of A. We just did the complement on B because we said the probability of not purple or orange. Okay, so the complement is, if you know what the probability is, you can take that and subtract it from the total possibilities. So you're from your 100% essentially. Okay, questions there? Okay, moving along. Of course, with probability, we sometimes have some word problems. A student-made target includes 2 overlapping squares. Assume that a sticky ball is thrown at the target and is equally likely to land anywhere on the target. What is the probability that the ball lands inside one or both of the squares? Okay, so you've got the picture. You've got the picture on your paper there. You can see the target set up. They have all the measurements we will possibly need. Probably the ball lands inside one or both of the squares. Thoughts on what we need to do here? Okay, we're talking area here, aren't we? They give us all the dimensions, and when we're talking find the probability, we're looking at the probability, we're looking in terms of area. So what's the area of these 2 squares out of what? The whole thing. Okay? Okay, so how about square A? Let's talk about square A. How do we do the area of square A? Area of square A is 10 times 10, because to do the area of a square, it's side times side, right? 10 times 10, which is what? 100, I'm going to say square centimeters, yes? What's the area of square B? So on my screen, it's the blue one. Okay, notice it's also 10 by 10, yes? This one was 10 by 10, this one was 10 by 10. 10 times 10 is, again, 100, yes? Now, if we're talking about landing in general in A or B, what's the probability the ball lands inside one or both of the squares? Well, A is what? A is 100 square meters. B is 100 square centimeters. What's the catch? There's an overlap, yes? Do we get to count that overlap fully? No. Okay, so the idea here, we're just looking at the total that they would have. We don't have the option to land in both of these corners here. So we need to subtract out that overlap. What is this overlap here? That overlap of A times B is 5 times 5, which is 25, yes? So as we look at the area of landing in A or B, we've got the 100 plus the 100, but we've got that overlap of 25, so subtract off the 25. What is 100 plus 100 minus 25? Okay. So the area in terms of landing inside A or B is 175 square centimeters. Okay, so some pre-work there. One other piece of information I need before I can find probability.
The whole thing.
The whole thing. How am I going to find the area of the whole thing? Okay, so this student-made target, obviously they're saying that you're going to land on the target somewhere. Okay, I guess there's not a chance of missing. So if that's the case, the entire thing is a 20 by 60, and 20 times 60 is 1,200. So, in order to do the probability that we land in square A or square B, what are we setting up?
Mathematically.
175 to 1,200.
Okay, you've got the 175 for A and B out of the entire possible outcomes, which is the 1,200. So 175 divided by 1,200. Does it reduce?
They can both divide by 5 at least.
Okay, so recognizing that they end in 5 or 0, they can both divide by 5. Do they divide by anything more than that? I'm honestly not sure. Okay, let's go with this. What's 175 divided by 5? What is it?
Well, they can't.
Well, then they're going to go farther. You said 35? Yeah. Okay. Well, we're going to go farther, because what's 1,200 divided by 5?
240.
No, they can divide by 5.
Oh my gosh. That was yeah. I don't know why I didn't. 175, that's a whole bunch of quarters. 1,200 is a whole bunch of quarters. Don't ask me, my brain didn't see it. We're dividing by 5 again. 35 divided by 5 is 7. 240 divided by 5. Did I hear 48?
48.
Okay. Sorry. Now, all that to show, can you take multiple steps to reduce? Surely. Just know to look. Okay, one option is 7/48. Guess I probably should have told you had the calculators at your seat. What's another way to express this? As a decimal, 0.14, should I see 583 or something like that?
583.
Okay. Which, as a percent, and I will say I have written down a whole number percent. What does this go to as a percent? Yeah, 14.5 or 6%, but then rounds to 15%. Okay. You guys realize to get that decimal, it was 7 divided by 48, right?
That saw this one. But in fractions. I don't think they'll make it.
I don't know. I feel like there was percents on some, but maybe I'm not remembering exactly.
Maybe like the perfect percent, like
Yeah.
this one.
I mean, here's the deal. Be ready, right? You know, probability comes in all shapes and forms, so be ready. Okay. A video game screen is a rectangle with dimensions 34 centimeters and 20 centimeters. A starship on the screen is made of two circles with radius 6 centimeters and overlapping area 20 square centimeters. A black hole appears randomly on the screen. What is the probability that it appears within the starship? What do you think we should probably do here? Okay. I'm going to say draw a picture so that we can find the area. Okay. A video game screen is a rectangle. Got my fancy rectangle. With dimensions 34 centimeters and 20 centimeters. A starship on the screen is made of two circles with radius 6 and overlapping areas. So two circles, what do you notice about these two circles? They have to overlap. Technically, they're supposed to be the same size. We're just going to go with it there, okay? So two circles, both circles have a radius of 6. An overlapping area of 20 square centimeters. Okay, that's that overlapping area there. A black hole appears randomly on the screen. What's the probability that it appears within the starship? Realizing, what's my starship? My starship is that thing right there, yes? Okay. I feel like this is a very basic graphic game here, but
So you want to give us a formula for the area of a circle?
we're high school. We don't know the formula for area of a circle.
They always gave it to us when we were at school.
2 pi r or pi r squared.
2 pi r is circumference of a circle.
Pi r.
Pi r squared is area of a circle. So,
They always gave it to us. I never tried.
let's see. So, it is something you should probably memorize. Area of a circle is pi r squared. I don't think Savas will give that to you. They'll say, know it. Okay. So, as we look at, what do we know about each circle here? Now, based on, well, there's two different ways we can do this. I'm not going to use my calculator to find the area of a circle. Okay. So, what do we know here? It's going to be pi, which in math, you're allowed to leave the pi symbol at times. Okay? Times, what's the radius? 6. 6 squared. What is 6 squared? 36. So one way you can express this is 36 pi. And we're going to leave it at that for the moment. The advantage of leaving it as 36 pi, I don't have to write a big, long, messy decimal, and I don't have to round my decimal too soon. That's my advantage, okay? Not saying the decimal answer is wrong here. Not at all what I'm saying. So, area being 36 square centimeters, 36 pi, this is the area of each circle, yes? Okay, so let's talk about the area of the starship. What's the area of the starship going to be? What are the pieces?
Pi
36 pi for one circle plus 36 pi for the other circle. And then we only count that centerpiece once, and there's an overlap area of 20, yes? So minus 20. Well, I know pi is a number, and your brains just automatically think pi is a number, but treat it like a variable for the moment. What is 36 pi plus 36 pi? 72 pi minus 20. So I'm going to talk about the starship being 72 pi minus 20. And I guess if you want a decimal, I guess I have both in my paper. What is the decimal?
163.3628.
What was your first numbers?
163.
Is that for 72 pi minus 20?
52 pi.
Why are you doing 52 pi?
Because 72 minus 12 is 52.
Ah, but can I subtract 72 pi minus 20?
Because it don't got a variable.
I don't think that matters.
It does to an extent.
206.19.
Okay,
That's got to roll.
so 72 pi minus 20. Well, pi is not a variable, it acts like it because it's 72 times pi minus 20. Sorry to say it's not 52 pi, okay? But, so, on your calculators, and I would have the calculators out as we practice this stuff, 72 times pi, whatever that is, minus 20. Those of you trying it, are you getting the 206 number? Okay. 206.1946711 is what I have currently written on my paper. Write as much or as little of that as you want. We're not done, right?
When I do it, it just tells me 72 pi.
I'll check here in a moment. There's a button somewhere that will change it to a decimal. Okay, but if you keep going and subtract 20, does it give you a decimal then? It might not.
Oh, it does.
Okay, but somewhere there's a button on there that you can hit that'll change it to a decimal. I just don't know off the top of my head. Okay, we want to know the probability that this black hole that randomly appears is within the starship. So I'm writing that as the probability of the starship. Okay, what's our setup here?
The 206 or whatever. 34.
Okay. The either 206, which you might have on your calculator screen, or the 72 pi minus 20, divided by,
16.
why 680?
Because that's what 24 times 20.
Okay, so we never found it, I'm realizing. The entire screen. How do I find the area of the entire screen? It's a rectangle, so 20 times 34, which is indeed 680. Okay, so 72 minus 20, 72 pi minus 20, divided by 680. If you have that 206 number, you did that on your calculator, then the 206 divided by the 680. Okay, I have written down 0.303. I also have this written as a percent, and that's actually what I have boxed. I have this written as a percent rounded to the nearest whole number.
30%.
So if we change this to a percent, 2 decimal places over, 30.3%, which is 30%. Okay, guys. I'm doing probability here, yes? I'm not doing anything fancy. I'm doing probability. It's just putting all the pieces together, okay? Yeah. The next piece on here talks about probability of non-mutually exclusive events, and that's kind of what we've done where we've added the 2 and subtracted the 3rd. So tomorrow we'll talk about rolling a pair of dice and what that means.
Fair die.
Yeah, we're all next.